Making a video. So I guess we'll start with comments, and then I'd like to be able to get to a list of bullet points. Again, another attempt to compress, you the complexity of our universe into just simple ideas and concepts that give you some general idea of what the rules are, of why it looks the way it does, what's the basic mechanisms. And those, I think, are sitting there right in front of us to describe. We can see that stuff. We can see the basic rules. So anyway, superior mind. I can see the point about human nature and easy answers. Would it be that protons are trapping most of the momentum? Okay, I would argue that it's kind of obvious that protons aren't, in the sense that the nucleus is small. And the smallness is kind of an indication of a lack of pressure. And they don't fly apart. They don't look like they're trying to fly apart. So it looks like their smallness is a place where that's their comfort, is to be small, to be close. So there isn't any pressure pushing them apart. There's an absence of pressure. So in fact, the strong force is an incredibly weak force, in the sense that it's the absence of any pressure that is allowing the protons to be compressed just by the atmospheric pressure, so to speak, the universal pressure. So they wouldn't be the mechanism that's collecting momentum, collecting force. And it seems kind of obvious that the electrons are the ones in the big ring, the wide ring. They're the ones containing a lot of pressure. And clearly they want to be somewhere else. They want to go to the proton, but they can't get to it. Okay, so there's a lack of pressure between them and the proton that they want to fill. And they can't get to it because of the pressure they're causing each other, because their repulsion is so strong. And the repulsion is strong because there's a bunch of stuff, a bunch of ping pong balls trapped between their paddles. So the protons have no ping pong balls, because there's an electron between all the protons. And that's letting all the ping pong balls out. So there's none between the protons. And the electrons, lots of pressure. Lots of what would be considered to be momentum trapped, causing most of the gravitation. So again, I would argue that what we call gravitation, we're seeing as weight, right? And the trick of weight is that it's momentum, all right? So mass and momentum are sort of related, in the sense that if I give this some velocity, as pointed out, if I make it a bullet, it's not going to have much mass in all these directions. I mean, if I put a moving bullet on a scale, it doesn't do this. It's not going to, it doesn't have much energy going in any directions. And what we're really measuring when we say something has mass is its energy in a direction. But it has a lot of energy, in the direction it's moving. A lot of mass. So if you just turned the bullet up this way and pretended it was gravity that was moving the bullet, you'd say it had a hell of a lot of gravity, because it bore a hole right through my hand. It was so heavy. It was so heavy that it bore a hole right through my hand. But that's all it really is, Momentum is all there is. And all we're looking for is causes of the momentum. I'm just arguing, as I will, in the bullet points, that matter bits are dead, except they're sticky. So they're sticky dead things. And there's a bunch of active little bits flying around, little flies. Okay, and the flies stick to the dead stuff, and they're still flapping their wings. All right, and so the dead stuff moves because there's a bunch of flies stuck to it. So it's just about what force you've collected decides what mass you have in a particular direction, and your mass is just your momentum. So you could argue that matter has no mass. It just has the momentum it's collected. I mean, electrons on their own don't seem to trap momentum. Well, go find an electron on its own. So that's an argument that I don't think you can make. because I don't think you can ever create a vessel for an electron where it's on its own, where you aren't pushing forces at it, flies, to keep it where it is. You're not letting it be free. Okay, there's no container for a free electron. There's no way you can contain an electron is to push it into a location and force it to stay in that location by constantly pushing it into that location. Alright, don't seem to trap momentum too well, so I'm wondering if it would be a required product of the combination in action. I think you're just making it more complicated than it needs to be. The two forces in interaction are the proton being the main workhorse, seeing as it is supposed to possess most of the mass. So again, their readings of mass are basically attempts to weigh things, and you're trying to pretend like you're weighing it independent of anything, right? I mean, that's how they detect mass, right? You're making this assumption that you can possibly weigh the object, you know, based on how much force it takes to move it. Well, how much force it takes to move it just has to do with how much force it's repelling the movement with, how much force it already has, how much momentum it already has. So there's huge assumptions built into these attempts to weigh things, because you don't, where's your pure environment? You know, how do you create the unbiased field environment to place the thing in? So, but what happens inside of atoms, the way they trap the force, gets into answering these sort of questions. I mean, how you sustain velocity, and so how you overcome the drag problem, for example, has to do with how the force is managed inside of atoms. That is, how it moves between the electrons and the protons, and that is important. But surpassing expectation, smiley face. Okay, I don't know exactly what that means, but I'll take it. You would think that if a plate could be made that could deflect some of the quanta from above and on the sides, that because you would be being pushed down unless you might have less effective weight, you would think if a plate could be made that could deflect some of the quanta from above. Well, you can't just deflect things. So the point is if you actually create any kind of reflection, technically you absorbed. All right. So you can only give. You have to always make an exchange. Nothing gets away with not somehow exchanging. In the sense, you can, if you take the force and it sticks to you, the fly sticks to me, then I don't have to necessarily exchange if that's all I do. But I'm just saying that technically you can sort of understand that in most interactions I have to let a fly go to put a new fly in its place. So most interactions are exchanges. Most things in most of the dead stuff in the universe, let's say, the electrons and the protons, have already lived long enough. I mean, have already been around long enough that they're covered in flies. Okay, so any fly that hits them has to make an exchange. One fly goes for the fly that you put on, and its wings are flapping in a different direction. So anyway, I wonder if it is possible to make some kind of quanta deflection plate that can deflect enough particles to lower your weight significantly. It's conservation of energy. So that's the problem. You can't, there is no way to there just isn't a way. There's no way to how to say it, because I'm not saying it's theoretically impossible to capture momentum, without giving something back, but the obvious point is that if you capture it, then the plate's going to move. There's no real way for the plate not to be in some way, unless it just makes a pure exchange, unless it just takes something in and it gives something back. Well, that's a pure exchange. And if it takes in the same thing that it gives back, well, then obviously nothing's going to change. See, how to put this. I mean, the conservation laws are kind of solid, so I know there's a lot of people who want to find some way to make some sort of magical vehicle that can overcome these rules. But I'm just saying, you're not going to do it. I don't think you have any hope. But I don't know exactly how to put in words the point that you have no hope. All right, you talked about the lack of rules for hypothetical fourth-dimensional objects. Yeah, I don't know if it's a complex subject, but okay, here's just one fact of 3 dimensions. 3 dimensions creates this kind of interesting fact that 2 of the dimensions are always on the same plane, okay, like left, right, up, down. And then forward, back would be on an opposite plane. And so no matter which one I change, by just tilting something, right, forward, back, and left, right are on the same plane, and then up, down aren't on the same plane anymore. Now, if you add a 4th dimension, you've broken that asymmetry somehow. Either 3 dimensions now have to be on the same plane and 1 is always off, or you've taken a circumstance where 1 dimension was off the plane and 2 were on, and now you're making it 2 and 2. So now you've made it symmetrical. So you've fundamentally changed the character of the 3 dimensions by adding a 4th dimension. The 3 dimensions can't have the same character because you've changed the character by adding the other dimension, because they had rules that worked in 3 dimensions, and those rules aren't going to work in 4 dimensions. That's what I'm arguing. And there's probably a ton of that stuff. I'm just giving you one example of the unique circumstance that 3 dimensions creates. I mean, you could probably get into plus and minus and just argue that you're going to create all kinds of sign difficulties if you create a 4th dimension. Because what's minus to the 4th dimension? The plus side? I mean, you're going to get into all kinds of how do you even assign a sign, a plus and a minus? Anyway, damn. So I gotta lean back. Let me just stop the back from hurting. I think that's better. You can model them on multiple 3-dimensional axes. Says you. And it should follow the same rules as single 3-dimensional bodies. So I'm saying no, it won't. Just because of the asymmetries that 3 dimensions creates. And 4 dimensions will break those asymmetries, and you're in big trouble. Although I don't think you could prove such things. Well, I think you can make logical arguments that you can't draw the 4th dimension, can't graph it, you can't access it even for the purpose of display. Where you could argue that, we don't really access the 3rd dimension, but we are able to simulate it. But we can't even simulate the 4th dimension. And that might give you some clue that, well, if you can't even simulate it, what's the chance that it really exists? Or could exist? So, the fact that you can create generalized mathematical functions that are supposed to be just generalized, okay, they're supposed to be very crude simplifications, and they don't apply a huge number of rules. And the fact that you can violate reality using math, because math doesn't have as many, you're not carrying all the rules of reality into the mathematical equation. The mathematical equation doesn't have all the rules of the reality. Like the mathematical equation could probably ignore, in most cases, that 2 of the dimensions are on the same plane and 1 is off plane. Maybe for most cases that doesn't mean anything. It only means something in maybe a Maxwell equation. So, so yes, your math can ignore structural facts because it's such a generalization, such a simplification. And so then that allows you to do things that are just stupid. So it's like Einstein's dilemma. Okay, I mean, he created this idea of the inverse square law being a bending in space, but he didn't put any limits on it. So he created this idea that you could just infinitely deepen the well. Do you think physical reality would say that was okay? You can have the infinitely deep well? Well, I would argue that no, there is a limit to how much force. There is a limit to the pressure the universe can create. And, because of this simplification and the fact that they turned it into a bit of math, well, the math didn't know the rule. The math doesn't know because it didn't include the fact that there's only so much pressure that the universe starts with. So you can't make the well deeper than the digger can dig. So you see what I'm saying? So let's see what I'm saying. There's rules about, if you were actually to make the well, there's rules about how far the digger can reach. And the math isn't going to include that rule that the digger arm is only so long, you can only dig so deep a hole. And so your math ends up allowing you to do things that you couldn't do in the reality. It's the big liability, and it's, it's just kind of funny that smart people can't figure out these weaknesses of these gross simplifications. That's what math is, gross simplifications. And they think because they have complex symbols in them, they think they're highly technical and specific when they're highly general and undetailed. All right. So these are some garbage comments I deleted. I just want to thank you for continuing to provide insight into your megalomania, whatever. It is rare to get a upfront camera view of someone who lacks a 5th grade knowledge of math. So I don't know where you just demonstrated any of this, right? You didn't prove. I mean, I can show you my high school records, all right? I mean, I did take trigonometry and did get straight B's in it. Anyway, physics and logic. Well, obviously, the whole conversation is about the credibility of what you call physics and what you think logic is. Like where you actually collect facts and see where the facts point. That's what I would say logic is. And apparently you think logic is you just make up a fucking story. Anyway, but who thinks he has solved the mysteries of the universe? Yeah, and they weren't that complicated. Frankly, in some respects, the solution was provided 350 years ago, and assholes like you pooed on it. So, I mean, it's not, the story isn't going to make you look very good, frankly. It's going to make you look insanely stupid because it's so fucking obvious that their course is irrational. Let's make bent space. Oh yeah, and it travels the same speed as virtual photons. And let's make these different things. I mean, it's overtly stupid. Alright, mostly by denying inconvenient experimental data. So it's just a huge lie. I'm sitting here saying, show me experiments. And when they do, I show how the experiment's flawed. So what do you want me to, I win. Again, I've pointed out clear facts about your assumptions about how two slits work or how interferometers work. You're just full of shit all over the place. So why don't you have the balls? Why don't you just man up and put your name on this crap? All right? You're making assertions, so why don't you put your name on them? Why don't you put your face on them? Why don't you come into a live room and defend your bullshit, asshole? Why don't you explain how it's the half silvering doesn't diffract light? Why don't you explain how it doesn't do that? With a dismissive says you. Yes, because most of what they're doing is just, that's the only appropriate response. Oh, there's magical matter that's invisible in every respect, that's, that has anything to do with us being able to detect it, except it's the most powerful force in the universe. Yeah, except it's invisible in every other way. Yeah. No, there's no evidence that it exists. I just made it up, and it fixes my broken math. I mean, what else can you say except says you to that crap? Your legitimate criticisms of mainstream physics are stolen from other people. So why don't you back that up? Please, somebody, point me to the video of the other person, the other rational person making rational arguments. Because frankly, all I found is a bunch of truther nuts who don't even know how to properly argue against Einstein and all these things. They keep arguing gimmicks. The stupid electric universe guy is arguing a stupid gimmick because Einstein recognizes that he can't create gravity unless he has two bodies in the equation. I mean, he can't explain to you how gravity works unless he puts something in the field to engage in the gravity process. Yes, there is no gravity, so to speak, until two objects are interacting with each other. That's the way it works. That's not a criticism of Einstein. You think that's a legitimate reason to dismiss his relativity theories? I think it's just a retarded reason. So, but go ahead, show me the person who's made my arguments for me better than me, or who has made even any of these arguments, any of the arguments I've made. Why don't you show me one person making the arguments I've made? It's just such a lie. I mean, it's just such an insane lie. If there was one other person out there talking something rational, I would have him displayed on my homepage. Go listen to this guy's video. He's great. I haven't found one fucking rational dissenter out there. They're all fucking nuts. Alright, anyway, without giving credit. Who do I give credit to? Show me the person I'm supposed to give credit to. Show me one other person making my arguments, my specific arguments. Show me. Show me the other guy pointing out how the interferometer is diffracting the light. The two beams aren't equal. Show me that argument made anywhere else. Show me. Amazing. Show me one other person talking about how the the photons going into the two-slit experiment are likely moving through the transition, the space we already know that diffracts light. Okay, when you go from one medium to another medium, there's this transition layer that screws the light up, bends it. We know it does it when it goes into water, when it goes into a prism, when it goes into all kinds of things. We know that's the layer that's causing it. It's a surface phenomenon. It happens on the surface. The diffraction happens on the surfaces. Show me the other person making the argument that, oh yeah, that's what's causing the diffraction in the light. You're forcing photons to plow right through a surface layer. Yes, they don't penetrate from one surface to the other, but they're traveling right through the surface layer. The same layer that diffracts light. You know, it's the same exact layer they're plowing through. Show me the person making that argument. I mean, you're such a fucking liar. It's disgusting, you know. But again, you're making it obvious that that's all you people have. You don't have a rational or counter argument. All you have is lies. Malicious lies. All right. Criticisms, okay, of other people without giving credit. So again, I'd love to give credit. So just give me the link. Give me the link to the other person who's saying the same thing I said on any one of these subjects. There's no one. Show me somebody who's made the same argument I'm making. Show me one fucking video, please. And any original criticisms you make, well, I thought you said I didn't have any of those, are laughably stupid and irrelevant. So point them out. Where did you defeat any of them? Where did you make any rational argument? Oh, that's right, you didn't. There is a reason why educated, intelligent critics of mainstream physics have not made these criticisms. So now he's agreeing that they are not making the same criticisms I'm making. Because the supposed faults exist not in the experiment, but only in your below 5th grade educated brain. So again, one minute he says they're legitimate criticisms, next minute he says they're not. And now he says the ones that aren't copies of somebody else, which first he hasn't even proven a single one of them is a copy of somebody else's idea. But he's making no distinction. So which arguments are you talking about? And why don't you argue the argument? Why don't you demonstrate how it's true that you know that the smaller you make the opening, the less the light diffracts? Why don't you show me the one experiment on planet Earth that demonstrates that? You're just such a despicable liar. Okay, anyway. I always look forward to see your next tantrum excommunicating anyone who injects a reality check into your cult dogma. So again, cult. What kind of cult is there? Where's the cult? Where's the members of the cult? No, there's one rational person on Earth and everyone else is a fucking idiot. Some degree of idiot. You know, and I'm going to prove it in the end. It's going to be demonstrated, and you're just going to look exactly like what you are. A cowardly weasel who just threw mud because that's all you could do. You have no power. You have no competence. You're so fucking pathetic. You can't make a stand-up argument of any kind. You're just some asshole who, you know, some crippled asshole who sticks his cane, you know, trying to trip other people and break their legs because you can't walk. Because you're a fucking mental cripple. You're just disgusting. Little fucking piece of crap that should be squished. And before you whine that I haven't provided specifics, you haven't provided evidence of any of this crap. You just made a ton of assertions. You defended it with nothing. You're just such a fucking slandering liar. Please understand that I do not want to set you straight. Regardless of what you want to do, you clearly are committing a crime in the sense that you have no evidence for your accusations. They are, you know they're lies because you have no evidence. All right, so you're just deliberately attempting to malign me, all right, because you're a petty, inverted dicked, crippled mental midget. I want to enjoy another 8 years of seeing your little cult. So again, this cult, what cult of where? Where's the cult? Of philosophy rejects playing. So in broken sentence to finish with. Ba-dum-bump. You know, you should finish with a rational sentence. Seeing your little cult of philosophy rejects playing make-believe physics. And again, you're the one who can't, in this whole fucking comment, you couldn't cite a single experiment, you couldn't quote me, you couldn't do a single fucking thing. You couldn't make a single bit of argument with any integrity at all. Not one single rational argument. And you're saying you're winning. You have all the evidence on your side. You have all the logic and reasoning on your side, yet you couldn't provide one fucking sentence of it. Yeah, no, you're losing, fucker. All right, so this other person, no, I don't know who this is the Ivan guy, okay. Okay, so I have two problems with your theory. Okay, so I'll try to get through this without too much crap. This relativity shit. I like it, but I think it has potential. But there are some issues that may need to be addressed, and pardon me. All right, so I've already read some of this stuff. Firstly, if you're on a spaceship, which for the sake of argument is, you know, why would I make a spaceship 300 million meters long? Anyway, and it's traveling half the speed of light. I mean, that's the length of, you know, from the Earth to the moon. You know, why would I, you know, but whatever. Suppose I shoot a laser from the back down the length of the ship and at a mirror in the front of the ship. How long does it take that photon to reach the mirror in your system? Well, yes, it takes longer because the mirror is moving away from the photon. I mean, duh. If it's moving away from the photon half the speed of light, obviously the mirror's not going to stay where it was when the photon left, so the distance is changing. So it has to travel more distance, quite obviously. The spaceship's moving away. Duh. I calculate it takes 2 seconds. Well, I'm not going to, fine. We'll just say fine for the sake of argument. Whereas if the ship was stationary, that same photon would reach the mirror and then return all the way to the laser in that same 2 seconds. Well, yes, if it's traveling half the amount of distance, because in the time it takes the photon to go the full distance, the mirror will move the full distance, you know, another 300 meters. So obviously the distance doubles for one trip. You know, so obviously you've doubled the distance. Well, you've actually 4 times the distance. You've doubled it on both trips. Whereas if the ship is stationary, that same photon would reach the mirror and then return all the way back to the laser in the same 2 seconds. But this is not experimentally confirmed. Well, duh. The Earth is moving, and there is no detectable difference in the speed of light here on Earth. There's never a difference in the speed of light. So again, this is just retarded. And again, so this goes back to some stupid, you think you can make a device, okay, where the emitters moving, okay, and the receivers moving. Okay, all the parts are moving. And so somehow you think you can create an experiment where you can detect the greater distance when the emitter's also moving. Now see, if we could shoot these single photons, if we could put a single photon in the Michelson-Morley experiment, well, there might be some hope. But there aren't single photons, are they? No, they're photons that take time to introduce to the experiment. So there's a certain amount of time taken, okay, in terms of the amount of photons to even be created, the time of their creation in the experiment. And it's continuing. So as the experiment's moving, each photon's being placed at a different place. It's obviously being blue shifted substantially. Lots of things are happening to it. And where is that in the experiment, right? You know, I mean, to some extent, Michelson-Morley, at least because they were using white light, they had some chance of seeing the blue shift. But wouldn't it be even better to use monochromatic light and see if you can see the blue shift? Because that would be also a consequence. But anyway, I don't know what to say. So you say there is no detectable difference because you say you have an experiment that can do that. I've already pointed out how interferometers don't have any hope, in my opinion, of doing that because you don't even understand how the light's moving. That is, it's spreading, which means it's obviously moving a greater distance just from the fact that it's not going from point A to point B. It's going from point A to point C and then being bent back to point B by the telescope. Clearly the photon's traveling a longer distance just because of the diffraction. You know, Secondly, it seems there are inconsistencies with your theory. Fuck you. For instance, you argue that matter bit is really a force bit. Yes, trapped in a square circle. I think I've already read this part. It cannot leave the circle because it gets hit by outgoing force bits. You know, there's really no point in arguing this in sentences like this. You know, because nobody can tell what you're talking about, really. I mean, I can, barely. A force bit trapped in a square circle. It doesn't matter how it's trapped. It doesn't matter whether it's 4 right turns or it's an actual circle or it's just going back and forth. The point is, it's trapped. It's not going anywhere. All right? It produces just as much movement this way as this way when it's trapped, which means it doesn't add to anything. It just sits in there. And the only thing the thing got from it was the initial bit. So if it flew in this way, whatever trapped it still has that little bit this way. Okay, so that mattered. The first impression is the only impression because all the rest of it is just circular. That is, it provides just as much momentum this way as it does this way once it's trapped. How to explain that? Something always comes in one way, all right? And that way still remains an imbalance. The first impression is the first imbalance. And you never undo that till you give the damn thing back. It's like somebody gives me something, you know, whatever, a marble. I have the weight until I get rid of the weight, till I throw it back to the world. But it doesn't mean much while I'm holding it. Anyway, it cannot leave this circle because it gets hit with oncoming force bits. So again, it's just stupid. I mean, look, I've explained that it's just ping pong paddles. You can't figure this out? There's ping pong paddles. The matter bits are like ping pong balls. They can trap ping pong balls bouncing between them. It's all there is. So you either add more ping pong balls to make force, or you bring the paddles closer together and that's more pressure. Why is this complicated for you? You understand the ping pong balls are trapped, right? If I have 2 paddles and the ball's bouncing back and forth, it's trapped, right? It's not going anywhere. But what's the consequence of the trap? Well, obviously, if they're this far away, it's only this much pressure, dun, 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 right? And if I bring them closer together, there's going to be twice as much pressure because they're going to have twice as many impacts. And each impact is exactly the same speed. So each impact is exactly the same momentum. So obviously, this means twice as much pressure as this. Duh. All right. Just beyond its vicinity. So one could argue that matter cannot move at all. Well, it's just stupid. On the other hand, you argue that matter bits acquire momentum whenever it is bombarded by other force bits. No, whenever it absorbs their energy. So yes, it has to absorb it. It has to collect it. The force has to be trapped. And what you're collecting is the initial, it came in my front door. And then whatever the hell it does doesn't matter. But the coming in my front door was the first move. It's like you're jumping on a boat off a pier. You jump onto the boat off the pier. You jump off the pier onto the boat. The boat starts to move. Well, everything you do when you're on the boat isn't going to matter now. But that first move mattered. Okay. What's more, you argue that it is not slowed by force bits coming towards it when it is moving. Well, I've made the simple argument that kinetically it's kind of impossible for this interaction to mean anything. Okay, when two things hit each other, the going through each other is exactly the same as hitting each other. A thing is going this way and a thing is going that way. So in a sense, head-on collisions can't mean anything in pure kinetics. They just can't add up to anything. So clearly there can't be any drag for that reason alone. Coming towards it when it is moving. To account for conservation of momentum, it would seem then that matter cannot hold still because it must constantly be bombarded by force bits beyond its direction of travel. So again, no. It's once I jump on the boat, as long as I jump off the boat, I won't cause any other momentum changes on the boat. So I jump onto the boat from the pier, and then I move around, do all kinds of stuff. But whatever I do, if I go over to this side of the boat and I go over to that side of the boat, whatever I do, I can't make the boat go anywhere. I can't change, because any movement I make has an equal but opposite reaction. If I move the top of my body this way, the boat goes that way. If I move the top of my body that way, the boat goes this way. I can't do anything to change the momentum of the boat until maybe there's a piece of land the boat's going to go next to. And now I jump off the boat onto the land. And what am I doing? Oh, I'm giving the momentum back to the boat again. Now I'm pushing the boat. Well, anyway, I can't do much for people. It is constantly be bombarded by force bits behind its direction of travel. Obviously, force bits behind something's movement are going to be much lamer than the ones ahead of it. But as I pointed out, it can't matter to a force bit. If I hit 10 million things coming at me head on, it can't matter if the exchange is 100% efficient. It's the same as not hitting anything at all. So I'm just saying it just doesn't matter that I hit 10 million more this way than I hit that hit me from behind. Well, it doesn't matter because the force bit has the momentum, and it's not giving it up to anything. It's keeping its momentum. So, so you're going to make this force argument when the force is attached to a piece of matter. And then the rules of the matter, as I pointed out, are going to be these kind of school of fish kind of argument about exchanges. But as I pointed out before, there's a trick to how matter works, and that's why electrons don't seem to have permanent velocity. They run out of gas. So the elemental bits don't do the throw them into space and they just keep going forever thing. They don't do that. All right? And only matter can do that. That means the more complex matter, atoms. So a certain size of nucleus is what's required to create something that can have permanent velocity. And it has permanent velocity because of how the force is moving through the matter. The trap's shape matters. And it can actually have a shape that's essentially a little bit of a motor. And it ends up being a boat with a motor. And that's the stuff that has permanent velocity. If you have a piece of matter moving through empty space, it's because it has force trapped in it, and the force is shaped in a direction, and it pushes more in one direction than it pushes in the opposite direction. Well, anyway, assuming it's going less than the speed of light, which all matter does all the time, Well, again, I already pointed out, you can make matter go the speed of light. It's just that you wouldn't call it matter anymore. If there's a school of fish and every single fish is moving exactly the same speed in exactly the same direction, you almost wouldn't call it a school of fish anymore, because now it's just a bunch of fish, a gang of fish, all moving the same speed, which would look like a laser beam of fish. All right, how do you explain this discrepancy, Mr. Know-It-All? Well, it has been explained in other videos on the subject of drag, so look up the drag videos. And yeah, I do plan on making more drag videos, but you know, I don't know what to say. So that's all you're really talking about, right? Is the drag argument. And the drag argument can only be understood by understanding the more complex polarization argument. So I guess that's part of the reason why, I mean, you really have to first understand the exchange rate. The fact that there is, the little elemental bits can do two things. They can exchange momentums, or they can allow the force to exchange momentums. That is, they don't change their momentum. They don't absorb a momentum and give away a momentum. They just allow force to interact and exchange momentums, exchange directions. So something red going this way ends up coming out as blue going this way and a red thing going this way. But the bit of matter doesn't change at all. And that's how the mechanism works. If you can change something's direction without changing your momentum, clearly, if you can make a force go from this way to going this way, so it's coming, it's going this way towards you, and you make it go out this way, well, clearly you can understand that that could create a V, and the V would be pushing this way and pushing this way, but it would never be pushing down. And so it would be all energy going this way and no energy going this way. Yeah, it's not even all that complicated, but clearly you have to understand. You have to be willing to understand, to look at the simple model of how these kinetic interactions take place. Yeah, you people just aren't willing. All right, so then this Jim Marcus guy, so, I mean, he's just an idiot. He really, I mean, I already called him retard, but, you know, it's really stupid. But you said that the atom bomb was a hoax perpetrated by the fascists. No, I didn't. And you said that the U.S. government was controlled by a secret government. No, I didn't. Look, Miles. So this guy, you know, this is probably just fake, right? I mean, nobody could really confuse me with Miles Mathis, right? I mean, our personalities couldn't be more different. I mean, Miles Mathis puts his name on everything all over the place. He doesn't say a word without saying, this is my name. He'd never call himself Draft Physics. I know you're trying to change your image. How do you know that? Where on Miles' page do they say, I'm changing my images and doing videos now? Where do you ever say that? But at least be polite when you respond to my comments. Obviously, you're an idiot. You're just an insane lunatic. There's absolutely no evidence that I am Miles Mathis. I don't say anything very similar to Miles Mathis in terms of my physics. So how can anybody with a brain be confused? Kinetics is simpler, more rudimentary than get bent space. Okay, that's one I already read. All right. Stop wasting time. What are you doing, dude? So, you know, a dude guy. I mean, just amazing. Amazing. Oh, yeah. That it just screams credibility. You know, when somebody gives me advice with dude stuck in there. All right. So maybe I'll save this for later. Oh, this comments kind of ate all my energy. Let's see. So we'll do a little bit of it. All right. The universe is just sticky dead matter and small fast force. So I'm just trying to get to the point where you could understand that all there is this force stuff. So just understand the electrons, the protons, the atoms, all of the matter stuff doesn't have any innate velocity. It only has its experience in the universe. That is, the universe had to act on it, you know. And it's like it's sticky. So it's like stuff does stick to it. But as I stated before, it sticks with a rule that if it already has some stuff stuck to it, it has to exchange. So to have this stick to it, it has to give up something going some other way. And that's the rule. So, you can sort of understand that if it has a bunch of stuff already stuck to it that's going in a direction very fast, like the bullet argument, the bullet's going very fast. For me to add speed to it, is going to be difficult, because I'm just going to keep hitting bits that are already going the speed you want to go. So I'll just be replacing a bit that's going that way with a bit that's going that way. And I'm not winning then. I can't gain any speed. So that's why it's harder to push something that's already moving. The faster it's moving, the harder it is to give it more speed. Because you can't make really good replacements. It's hard to hit the bit that's going the wrong way, and that's what you really need to do. But there aren't too many of those left. So how else can I make this understood? So the matter doesn't have any innate velocity. So in a sense, you could just say that you just drop it into the universe, and it doesn't want to do anything. And it's not going to do anything unless there's some imbalance in the force around it to make it do it. Just like I don't fall towards the earth because I want to, or because my matter says I should. I fall because there's actually more force hitting me from one direction, saying go down and sticking, than there is stuff sticking going the other way. And so I just end up acquiring more stuff stuck on me that's going down than stuff stuck on me that's going up. And that's what happens to me. So I just do whatever the force tells me to. Matter doesn't control anything. It's just a slave to whatever force has previously stuck to it, and how that layer of what's stuck to me interacts with the new stuff I encounter. So the bullet is just a byproduct of the little force bits, the fast moving shit that's pushed it and stuck to it. And now it travels with a bunch of these little force bits going in the direction. And depending on what it encounters, those little force bits can fly off. So it hits certain substances, it'll either just plow through them, or it'll release a whole bunch of those little force bits. And that's all the universe is doing. There's nothing else happening. There's just little bits going the speed of light, and dead bits that are just obedient to whatever the force tells it. And they have a little bit of a memory, so to speak. They're stuck with what previously has happened to them. And what's previously happened to them decides their momentum. The Earth has a momentum around the sun, a velocity. It got that velocity from something that happened to the Earth before it got to our solar system. Something happened to the Earth. It had a history, and that's where the velocity came from. Alright, c equals the speed of force. So that's just a change that everybody, it's just everybody should be agreeable to. It's just time to quit pretending that the speed of light is the speed of light. It's not the speed of light. It's the speed of everything that is made of these little bits of energy. All the forces are moving that speed. All the forces are made out of the same stuff that light is made out of. There's just the force in different forms. It can be at a frequency, it can not be at a frequency, it can be segregated for north and south, or plus or minus. It can come in different forms, but it's all the same little bits moving the speed of force. Alright, no force equals no field. So if there's not a force happening, there's no field that sits there and says, I'm waiting for force to happen. There's no field to interfere with. There's either, there's either force or nothing. There's either the stuff, the soldiers. The soldiers are either going across the enemy lines, or you don't say there's a battlefield. So the battlefield is not a battlefield. It's not any of that stuff until there's something battling. So if there's no soldiers, there's no battlefield. There's no field. It's just nice flowers and shit. Momentum starts with force. So that's just another restatement of the same thing, just understanding that the little force bits are the only thing that has movement. And all it's really doing is sticking to the matter bits and giving them the ability to move. But they only have movement because a bit of force has stuck to them. They now possess it. It's come in their door and it hasn't left. It's on the boat. The force bits jump on the boat. Alright, and you collect them. And whatever you've collected as force bits defines your motion. And you will encounter new force bits that jump on your boat. And as they jump on your boat, the boat can only hold so many. Other force bits have to leave. And that's how it works. You just start exchanging force bits with the universe. Interaction is an exchange of... force equals the kernel of momentum. So yeah, if you just think of that, momentum just doesn't exist until the boat just sits there until something jumps on it. And if the boat has been in the universe a while, and it's just sitting there, well, that means it has an equal number of bits sitting in the boat, the same number going this way as that, who jumped in going that way, as jumped in going this way, as jumped in going that way, as jumped in going that way. So it's balanced. And if you're all moving in a way, that is, you all have a bias in a direction where you have that same bias, then the boat has 3 people going this way. But the pier also has 3 going this way. So, the relative motion thing kind of breaks the analogy. But the point is that the boat has a circumstance that's dictated by its history. And now new things will happen to it. New things will jump in and new other things have to jump out. It's just that simple. Where it was, where it has been, its history is changed. It gives away a piece of its history for its new future. The bullet sits in the gun saying everything's just fine, and all of a sudden everything isn't just fine. It's going 10,000 miles an hour. It's changed by force. It's not changed by anything else. A bunch of force jumped in the damn boat. Interaction is an exchange of force bit momentum. Force / bit momentum. Kind of obvious. So every time 2 things bang into each other, a bunch of force is being exchanged. This thing pushes on this thing pushes on this thing, the force bits do. The matter never interacts with the matter. It just keeps interacting with the fact that everything's radiating this force, which is one of the talking points here. An accelerating charge. A charge changing speed momentum radiates exchanged force. So when they talk about an accelerating charge creating a magnetic field, no, it's just creating the same field you're creating all the time. You're reflecting the energy that hits you, and some of the energy goes straight through you and some of it reflects. It's all kinds of stuff, but you're radiating every bit of energy that hits you. You're radiating back eventually, but you're at equilibrium. But when you're not at equilibrium, that is when you're changing, you're moving, you're accelerating, you're changing your direction, well, then you're going to radiate a little bit differently, because now you're making real exchanges. You're exchanging stuff that was going, say, this way for stuff going this way. So you're making real exchanges. You're changing the character of the boat and which way it will continue to sail. You're unbalancing it. You're creating more people rowing, paddling that way than people on the other side paddling that way. And now you're going to have a momentum. And so to have that change in direction, you have to give up an old direction. So everything's radiating force. But when you're specifically changing your momentum, then you're going to radiate force with biases in it. You're going to radiate force, you're going to be giving up paddlers, okay, in certain directions. And those paddlers are going to hit somebody else's boat. So you're going to see the effect. That's the magnetic field. You're going to see the effect that when I went this way, I changed my momentum. I went from 0 miles an hour in this direction to 10 miles an hour in this direction, and to do it I gave up 5 miles an hour this way and that way. So now I've pushed other boats away from me, left and right, because those paddlers are going to hit those boats, jump into those boats, and paddle that way, and then they're going to give up some paddler going some other stupid way. But that's all we're doing. We're just exchanging paddlers. That's what matter is doing. Things can only exchange what they have more of. Well, no, I want to do this one. All matter radiates a reflection of the force environment they are in. So when you're not accelerating, when you're not changing, when your boat is just sitting and nothing obvious is jumping into it, well, the truth is everything's jumping into it still, but it's jumping equally from all directions. And the only thing that happens when you're near the pier is that when you're near the pier, more stuff can jump from one direction than some other direction. So it changes your bias. But we're all radiating energy all the time. We're all reflecting what the universe is hitting us with. We're all readmitting or reflecting, however you want to look at it. All right. Weight equals movement equals velocity equals mass momentum. So this is the tricky part. That the matter essentially doesn't have any mass. You could say the boat has no mass because it originally has no momentum. And momentum really is the only thing that really makes somebody massive. Your movement is what gives you mass or weight. You have to move onto the scale to have weight. So you really don't have mass unless you have stuff going in that direction. And your native state is to have stuff going in all directions. You have paddlers on all sides of your boat. So if I try to measure your mass, well, maybe I can detect those paddlers. But the only thing that's really going to make it visible is the boat has to move. There has to be an imbalance. I can only really measure imbalances. I can't really measure balance and call it mass. And the only way to do that is to say, well, how much of a difference does it make when I change one person in the boat? So when I take one person out and put one new person in, how much does it change the direction you go in? So the mass is really just an equivalency to how much momentum you can hold, how many paddlers. So the paddlers have the mass, not really the boat. All right, things can only exchange what they have more of. So it's just a probability argument. So if there's 20 people paddling on the left side of the boat and only one person paddling the right side, and I'm going to do an exchange, and it's going to be just kind of random. Well, by probability law, I'm going to more likely exchange with the ones paddling left than the one paddling right. So over time, I'm going to make more left to right exchanges than I'm going to make right to left exchanges, or forward to left versus forward to right, just by the laws of probability. So it's easy to change something when you're an opposing force, and difficult to change when you're a complementary force. It's hard to accelerate something already moving in the direction of your acceleration, and easy to decelerate something that's moving opposite to your movement. Okay. Stuff only has mass and the direction is moving. It's a component, So that's when you get into this vector crap, because every line has a 90-degree vector down its middle, 45 to 45, and these could be recognized as the actual thing that made this direction. So if you have this direction, it could be made out of this direction, or this direction, or this direction. Anything above the 180. And that's where you get into the dimensional, the 6-dimensional arguments. Up, down, left, right, forward, back. 6 dimensions, essentially. But the real point is that's your mass. Your mass is made of anybody paddling in that 180 degrees, okay, from that direction can be a component of your direction. But anyway, the point is you only have weight, and you have to have a paddler to have weight. You have to have a paddler in some plane of that 180 degrees to have any weight in that direction. For the boat to have any movement in this direction, it has to have at least one paddler who's at least paddling with some portion in that dimension. Something in the 180 degree arc. Okay, yeah, that's probably enough. Alright, so we'll probably get back to these things and rephrase them, but I don't think anybody can make any serious challenge to these as basic concepts, and it's just that simple, really. There's nothing else happening here. Force is a real thing. It contains real momentum, and that momentum does in fact stick to matter. And then the matter carries the force to some new location where it releases it. It's just that simple. The force never dies, and the matter just temporarily moves around and carries the force to different locations at a much slower speed than the force was actually going. And that's all that changes. That's all the universe is made out of, in its simplest form. Again, the polarization part is really important to understand the true function. You know, the idea that there is a electron force and a proton force, but you know, the basic concept is still just acquisition of momentum and exchange. The fact that you can't acquire it without giving something back to the universe. Fundamentally. Okay, well, that's probably enough now. So, till the next time and such, so forth and whatnot.